for thank you for having me a chance to be there with you, and thank you for coming. My name is Vitaliy, and right before we start, I have a question for you guys. How do you store and name your dashboards? Well, look at that. All objects are stored in one place, named perfectly well, right? We are store dashboards like that, right? I'm sorry, but not. It's wrong. If deadline is close enough, dashboard creation goes over control. But even then, we don't want to change or delete this Igor folder right there. Yeah, by the way, Igor left the company 2 years ago. And also, I forgot to mention that we have 2 servers, and due to security reasons, we cannot merge them in one server. So is it a joke? Maybe. But that's exactly what I found when I first looked into my new colleagues' reporting service. So it's just one of many examples that turning your life of your business users into a nightmare and continuous back and forth communication with you to just figure out where did I see this LTV report that you showed me last week, or where can I find the dashboard that contains MAU or some other metric. So that's the questions that users are asking every day, and on a daily basis they are struggling. Let me just quickly introduce myself and why am I presenting today. As I've said before, my name is Vitaliy, and I am the head of BI in Yandex FinTech. I have experience in both data and BI analytics, and I'm currently focusing on building data workflows, reporting, automations, and managing BI infrastructure. Okay, so what to expect from this presentation? First, I will tell you why did I choose to do something with our search. Second, it's some implementation details and my concerns and my conclusions that I've made so far. And I'm trying to explain and answer some questions at the end of my presentation. So, all right, why and when do you need to do something with your search? Let's take my company as example. Our company growing really fast. We have 100 analysts and 1,400 users. Our analytics teams makes a lot of dashboards, and quality of those dashboards are not so great, along with naming and this allocations and so on. So and also our BI team, as I've said before, divided on 2 clusters. So even if you have best naming and best location, I don't know, practices, you cannot find something because even if it is one domain, you cannot find all of the dashboards. So you could say that we can just apply some data catalog for that. But we have our own decision, as we Yandex want and love to create, as we said, bicycles. So that solution does not really fit well. And if you have a centralized BI team and use all the best practices, it's not really your case. You could be really, you could feel really better in comparison to us. Or if you have only 10 dashboards and that's it, something like RAG, it's not for you, just beat it and and so on. So, but otherwise, it could really help you. So what is RAG, essentially? If you have ever used ChatGPT, for example, if you asked a specific question about your data that was not the part of initial training, you see that LLM would hallucinate and just write you a complete nonsense, like I want link, and it said you just need to go to your server and so on and so forth. So to reduce that, you could retrain the model, right, with your specific data. But it requires to be that guy or to have a team of ML engineers, or to create some cluster of video cards inside your garage, or just put it on in a cloud infrastructure, yeah, and also you need to redo all that stuff when the new data shows up. So it's not really easy task to do. So RAG, it's retrieval augmented generation, allows you to avoid expensive retraining of the model. You just could have your data inside your LLM call. So the process is basically based on two steps. First is when you convert your specific data into things called embeddings. And the user question. Then you apply some searching algorithm, and you find the most relevant documents that could answer the question of the user. Like, for example, where can I find LTV? And if some chart contains that LTV, probably you have some document within that. And then you just pass this the most relevant documents to the LLM, and it have the facts to answer you properly. So that's the main technology, and I will explain it to you further. For my specific needs, I choose Telegram bot as an interface, but it doesn't matter. I asked bot to find me a report about quality of my dashboards, and with some level of confidence, it gave me 3 options. And first of it, it's really nice. So we have here the number of views, why it gave me this dashboard, and the level of confidence. Also, I could report it back and so on. But how does it work? And what do you need? First, you need some metadata to search through. Any BI tool requires some effort to get this data. As we mentioned before, in Tableau, it's XML files, and sometimes they are really messy with IDs and no other things inside. But it's really important because, two reasons. One, it's without it, you cannot do anything. And second, that metadata could be reused in other processes, like dashboard certification or data lineage or something like that. Also, you need to prepare your metadata, find a proper embedding model to vectorize it. It's on the first stage. And write the code that handle this thing. And after that, you need to do some prompt engineering stuff, just to put it all together, and you basically finished. You could later you could wrap it up with some interface, but it's really a simple step. The most effort would be at step 1, because metadata is really important. So to create an interface like a chatbot, you can use Cursor or something like that, and it's a matter of days. In my case, I had metadata before the launch, and I created it for 3 days. So it's not so complicated task. And I even not an engineer, so. So let's talk about the metadata. As you can see on the screen, I use simple text. The main task of the bot is to provide me the link. So link is the core entity of the whole process. That's because I have some general info about this tab, or in Tableau terms, it is view, and some general information about it. It's the main, tab name, number of views, path, short description, etc. And then I have a block of chart details. For example, I could have some chart that named like that, and it is a fields, dimensions, measures, etc. Also, I have this red colored characters. As you can see, there's all my separators. I need it because this could be a really big document. And models that convert in our text documents into vectors could not have a limits. So you need to ensure that your text is small enough to fit these limits. So the most important question on that stage is what model should you use and how to split the document. So I personally use E5 made by Microsoft Research Lab. It has a limit of 512 tokens and support 100 languages, including Serbian and Russian. So you can use that in any situation. So the thing is, your users, when they will ask questions, could use any of those 100 languages. And the answer could be found on those 100 languages. Then you just apply LLM, and if LLM API supports this language to answer in those the same, you could use that as well. So limitations are calculated in tokens. Tokens, for the sake of simplicity, we will say that tokens mean words. Sorry, AI gang, but that's it. So to chunk our documents, as I've said, I have those separators, and also because I would find, and the algorithm will find chunks, not the documents at the whole. I need some metadata for the chunk. Some important metadata for the chunk. And those are domain, tab name, URL, and number of views. So after that, I have this kind of things that the whole other document text. And in this example, as you can see, due to absence of separator, and that's a really long text in total, some data could be truncated. So if you have a table this big, it could truncate it for this column. Yeah, and some of users would not get the answers to their questions. That number for me it's 1% of whole my data, but you could use some tricks to just shrink it a little bit to fit the limits. So we are now stepping into similar search. And it's, it's the most important, but the most, I guess, complicated to explain. So let's talk about cousin similarity, but I prepared for you a great example. Let's say you want to create Tinder for sentences. And sentence 1 said that I love dogs and I'm addicted to coffee. Yeah? And the sentence profiles that we would compare you as a sentence with another sentences, it's dogs are great and I drink coffee every morning, cats are the best and tea is life, and I enjoy coffee while petting my dog. As you can see, you are here as a vector. So you really like dogs, and you will kill for a coffee. And number 1 and number 3 are your matches, and number 2 is completely off. That's why it is red thing over there. Yeah. So it's basically how cousin similarity works. It calculates the alignment of the vector and calculates if they're looking in the same direction. So that's why it called like that. Yeah. So now I guess you know what cousin similarity is, and it is the simplest way to compare some vectors. And you have some kind of ready-to-use tools to use the cousin similarity. You don't need really to excel in this algorithm itself. You just could use it, but use it wisely. Yeah. And for local files, it's Facebook AI similarity search, and for Postgres, if you have one, it's PG vector plugin. So it could use just cousin similarity as a function. So it's not really a big deal. Second thing, before you launch, you need to optimize 2 metrics. First is recall, and second is precision. So I have some notes for recall. Yeah. I'm sorry. Yeah. The basic goal is to optimize those metrics till these stages. Like recall should be something around 80%, precision should be 70%. And it's basically the share of successful searches. To calculate those metrics, you need to create a golden data set that contains 50 questions. And some answers and some answers with IDs of the chunks that algorithm should find. And then you just launch your algorithm 50 times and calculate those metrics before you launch. So recall, it's the number of found relevant chunks divided by number of chunks that you defined in your the golden data set. And precision, it's the same number above, and but from the bottom, it's retrieved. It's number of all chunks that algorithm have found. So you could start with this synthetic data set, and you could also use this top key parameter. Yeah. So you could start with low number of documents that you need to prepare answer, and then just increasing this number and look for recall and precision and how it will go. Yeah. So now you know what similarity search is, and now it's time for the fun part. It's prompt generating. So if we have our chunks, it's a context right here. And also we have task and restrictions for this task. So you're an assistant for searching BI dashboards, use only provided context. That's why it will not answer you, go to your report and just launch it. If the nothing have found, it just says this. Sorry, I couldn't find a suitable report. You can check your reporting landing. Yeah, so I have this answer format in the same, I don't know, prompt and some sort of answer format. Also, in this first part, it is business context over there. So you could add some more details for rephrases or follow-up questions of the LLM. So if you have some company that sell paper and a wholesale company, you could just rephrase the question to find more relevant documents. And if you just says GMV, that will ask you, I don't know what you're talking about, but maybe you meant paper clips GMV, and user will rephrase the answer, rephrase the question. Yeah. So what's next? That's a really good question. There's some questions, like for example, can I improve similarity search, make it not just cousin similarity, but it's really not so advanced technology. It's known for years. Is there limitations of top K that we could use, so, and etc.? And do you have ready-to-go libraries to do all that stuff? And that's some of the answers. So you could use top K regarding and keeping in mind that your GPT that you're using have limitations of context in tokens, right? So the whole text that I mentioned before and the documents should fit into this limit. And if you use DeepSeek like I do, it's only 64,000 tokens, and it could fit around 150 chunks if there is no other text. But due to we have really wide text in our prompt, it reduces. So you need to think of that, or to choose another model if you're not afraid for your data, like ChatGPT. And you could use some strategies to improve search. As I've said before, there's two steps, could be with another one generation. So you could get the question of the user and rephrase it with some kind of knowledge that you have about the business. So, for example, if the user asking what is the MAO, and knowing that we have 5 products with MAO, it could rephrase those that question and find and go search in 5 different directions. to look it up. And then just provide the most relevant, keeping in mind who is writing to the bot. So you could use your Staff API, like for example, you have some kind of title of your user, like for example, he is from sales. That's why we think that the sales column of these documents are more important than the other. So that's how you could improve your search. And you could use LangChain Python library just to put it all together. And some useful tips, and I will finish. My tips for you is start with something small and simple. Try to launch as fast as you can to get feedback, because user questions are really not that you're expecting. Yeah. So they really ask a lot of questions, and they are really diverse. So you would be surprised. And also you can use search history, user position, as I've said, into your prompts and combine it to your prompt. So that's it. Once again, thank you for listening. And I have examples and GitHub repository that you could just try it yourself and just figure out, do you like it or not? And the Medium article that with all the code examples, and you just use it as you want. So thank you so much, and I'll be happy to discuss with you technical details and the adoption side of this process. Thank you.